morning. Hello everyone. We are from Group 3 with members Sarah Adilisa Kartini, Shefirstia Hana, and Muhammad Rizky Wafyan. Today we will present a laboratory report with the title Basic Laboratory Techniques. We previously experiment with this topic in the once general chemistry experiment course during our first semester. Next. Purpose. Identify several kinds of simple tools and their use, able to make and determine the properties of a gas, able to make dilution with a volumetric plate, able to perform concentrated H2SO4 dilution, able to carry out a filtering mechanism, able to perform an acid-base filtration and determine HCl concentration, able to perform actions that must be done when an accident occurs in the laboratory. Next, basic theory. Chemical laboratories are important facilities for education, research, service, and quality testing. Given the differences in function, there are also differences in the design, facilities, and use of material as well as the priority of the equipment required. However, when viewed from the aspect of work safety, chemical laboratories have the same basic hazards as a result of the use of chemical and their techniques. In the following, we will introduce some simple tools and their use. You can see test tube. The function of the test tube is to mix, accommodate, and heat liquid or solid chemicals, especially for qualitative tests. And graduate cylinder. The function of the graduate cylinder is as a tool for measuring the volume of a solution, ranging from 10 ml to 2 liters in volume. Allen flash. The function of the Allen flash is to mix, measure, and store liquid. Test tube press. The function of the test tube press is as a place to store the test tube dry and keep the test tube from getting moldy. Wire gloves. The wire gloves is also supported by a tripod at the bottom to make the heating process run optimally. Burette. Burette is usually used for filtration with high precision, or it can also be used to measure the volume of a solution. Fan funnel. The function of this funnel is to help enter fluid from the one place to another. Dropper pipette. The function of the dropper pipette is to take a liquid in the number of drops and move it to certain containers. Bunsen burner. The function of Bunsen burner is to heat a liquid that requires heat energy when the reaction process is carried out. Clamp and static. This tool is usually used for clamping and burette, for sealing flash, and other tools that require a clamp. Waste bottle. Usually these bottles are used to store distilled water which is used to clean or waste medical equipment. Evaporating dish. The function is to evaporate non-volatile substances. Mortar and pestle. This tool used to smooth a substance that is still solid or glycerin. Dropper. This tool used to move a solution from one place to another. Pipette. This tool used to collect liquid in a certain size. Utility clamp. This tool used to clamp large chemical tools. Thermometer. The function of thermometer is to measure the temperature of a solution or incubator stage. Beaker glass. This tool used to take a sufficient amount of liquid to be measured. Spatula. This tool to take chemical in the form of solid and to be used to stir the solution. Crucible. This tool used to heat metal. Iron rings. This tool to clamp the separating funnel in the separation process and To press the funnel in the drying process. Clay triangle. This tool to hold the container, for example a crucible when heating or a funnel when filtering. Safety goggles. This tool to protect the eyes from substances that cause irritation. Stainless glass function in clothing when heating the sample beaker. Space when weighing chemical. Flash for drying the solid in a desiccator, and many more tools and functions in chemical laboratory. Next, preparation and introduction of gas. An H3 gas is a gas that has some odor. This gas can be made by reacting a solution of ammonium chloride with sodium chloride and oxygen. Reaction with a volumetric test. A measuring flash is used for setting up an accurate volume. This test in step like a long making it easier for the practitioner to make a correct dilution with the solvent to the limit mark. Dilution of concentrated H2SO4. The procedure for preparing a less concentrated solution from a more concentrated solution is called dilution. Yang 2005. Dilution of concentrated H2SO4 solution is carried out by pouring concentrated H2SO4 gradually into the solvent or water. Next, filtering is a method of separation. This is a way to separate a precipitate from a solution. Acid-base titration. An acid-base titration is a neutralizing reaction in the titration of a base solution with a standard acid solution. It is called acidometry. Or vice versa in the titration of an acid solution with a standard base solution called alkalimetry. Titration aims to determine the amount of acid or base that is chemically acceptably equivalent to the number of bases or acids in the solution. The point when the step is reached is called the equivalence point or endpoint, while the point when the indicator color changes are called the endpoint. Next, label and symbol. Labeling is necessary so that we know quickly one explosive hazard explosive under certain conditions. Example, ammonium nitrate, nitrocellulose, NC. Safety, avoid impact, friction, fire jump, and head to oxidizing. Hazard, oxidizing again can ignite other materials, cause fire, or cause difficulty fighting. Example, hydrogen peroxide and potassium perchlorate. Safety, avoid heat and combustible material and reducing agents. Flammable, hazard flammable. Example, butane and propane. Safety, avoid mixture with air and avoid source of ignition. Toxic, hazard, toxic, dangerous to health in if inhaled, swallowed, or in contact with skin and may be lethal. Example, arsenic trichloride and mercury chloride. Where avoid contact or enter the body, seek medical attention immediately if poisoning is possible. Harmful, hazard, cause minor damage to the body. Example, pteridine. Safety, avoid contact with body or avoid inhalation. Seek medical attention immediately if poisoning is possible. Corrosive, hazard, corrosive or damaging to human tissue. Example, chlorine and sulfur dioxide. Safety, avoid inhalation. ecological disturbance. Example, tributyl in chloride, tetrachloromethane, and petroleum gasoline. We avoid direct discharge into the environment. Instruction for how the chemical laboratory works. Irritant. Hazard irritation to skin, eyes, and breathing apparatus. Example, ammonia and benzyl chloride. Safety, avoid inhalation, and contact with skin and eye. Next, for how the chemical laboratory works. The picture shows the picture shows how to smell a substance. Wash or fan the foam toward your nose with the one hand. Then put your nose over the container and inhale the foam. How to take solution with gas is set from a bottle. The picture shows how to pour the paper and how to pour the solution. On the left, the picture shows how to reach the height of the solution in a measuring cup and how to mix the
Okay, next tools and materials. For experiment 1, preparation and introduction of a gas, we need test tube, tongs, spiritus tube, match, red litmus, blue litmus, ammonium chloride crystal plus minus 0.5 gram, 3 milliliter natrium hydroxide solution 2 molar, and spiritus. For experiment 2, we need a volumetric pipette, volumetric flask, dropper pipette, and 50 milliliter hydrogen chloride solution 0.1 molar. For experiment 2, dilution using volumetric flask. For experiment 3, dilution of concentrated sulfuric acid, we need graduated cylinder, big test tube, graduated pipette, and a 1 milliliter sulfuric acid concentrated, 5 milliliter pure water. And for experiment 4, filtration, we need test tube, filter paper, funnel, Erlenmeyer flask, stirring rod, 5 milliliter pure water, 1 milliliter sulfuric acid, and 5 milliliter lead acetate 0.1 molar. And for experiment 5, acid-base titration, we need materials 10 milliliter hydrogen chloride solution, 3 milliliter phenolphthalein indicator, and natrium hydroxide solution 0.1 molar. For tools, we need graduate pipette, Erlenmeyer flask 50 milliliter or 100 milliliter, burette, and burette clamp. Procedure for experiment 1, preparation and introduction of a gas. Ammonium chloride crystal plus minus 0.5 gram is taken and inserted to the test tub. Is added by 3 milliliter natrium hydroxide solution 2 molar. The test tube is held by tongs. The test tube is heated while shaking slightly, leaning towards the empty place until it boils. Then, the solution is kept so as not to get out by means of the tube is lifted from the fire if the solution starts to rise. After that, we smell by hand fanning and note the smell of a gas and observe change in substance before and after the reaction. The red litmus is placed near the mouth of the tube and observe the change in color, give conclusion. Procedure experiment 2, dilution using volumetric flask. Hydrogen chloride solution 0.1 molar 50 milliliter is made using graduated pipette. The line on the graduated pipette must be exactly the minuscule tangen to it. It's put in volumetric flask and is diluted with added pure water little by little to mark the limit. Dropper pipette is used for added pure water when approaching the boundary mark. Next, experiment 3, procedure for dilution of concentrated sulfuric acid. 5 milliliter of pure water is taken by graduated cylinder and is poured to a big test tube. 1 milliliter sulfuric acid is taken by graduated pipette and put in a test tube filled with water. Note the change in heat before and after adding concentrated sulfuric acid into the test tube. Experiment 4, filtration. 5 milliliter of lead acetate 0.1 molar is poured into the test tube and is added by 1 milliliter sulfuric acid into the test tube. Observe what happened and recorded the color. Filter paper that has been for 1/4 circle is taken and placed in the funnel. Filter paper moistened with water until the paper attached to the wall of the funnel. Funnel is placed on top of Erlenmeyer flask, and the solution to be filtered is poured into the funnel with the help of a stirrer. Last, experiment 5, procedure acid-base titration. 10 milliliter of hydrogen chloride solution. The dilution of that result is taken using graduated pipette and is poured into the Erlenmeyer 50 milliliter or 100 milliliter. Is added by 3 drops of phenolphthalein indicator into the solution. Note the color of the solution and note the volume of natrium hydroxide solution when the solution is light pink. The titration is repeated until constant results are obtained and calculated the actual hydrogen chloride concentration. After we finish the procedure, we get observation data. For experiment 1, preparation and introduction of a gas, ammonium chloride crystal plus min 0.5 gram plus 3 milliliter natrium hydroxide 2 molar, we get the solution color before reaction is colorless and after reaction is colorless too. For the other, before reaction is odorless, but after reaction the odor is smell like urine. Litmus color before reaction is red and after reaction is blue. Reaction equation in this experiment is ammonium chloride solid plus natrium hydroxide aqueous produce natrium chloride aqueous and ammonia gas plus and water in liquid. Experiment 2, dilution using volumetric flask. Hydrogen chloride 0.1 molar 50 milliliter plus 25 milliliter pure water. Before reaction, the volume is 25 milliliter and molar is 0.2 molar, and after reaction, volume is 50 milliliter and molar is 0.1 molar. For reaction equation, no chemical reaction because only dilution of hydrogen chloride. Experiment 3, dilution of concentrated sulfuric acid. Sulfuric acid concentrated 1 milliliter plus 5 milliliter of pure water. Before added sulfuric acid, the temperature is normal, but after added sulfuric acid, the temperature is rise and to be a hot. For the color of solution, uh, before and after added sulfuric acid is still colorless. Reaction equation for the experiment 3, sulfuric acid aqueous plus water aqueous produce H3O plus aqueous and HSO4 min. Experiment for filtration. Lead acetate solution 0.1 molar 5 milliliter plus sulfuric acid solution 1 milliliter. The solution color before reaction is colorless. After reaction is like white or white foam. For filtering, filtrate is acetic acid, and for residue is lead to sulfur. Reaction equation, lead acetate aqueous plus sulfuric acid aqueous produce 2 acetic acid aqueous and lead to acetate in solid. Observation data experiment 5 acid base titration 10 milliliter hydrogen chloride 0.1 molar plus 3 drops phenolphthalein indicator plus natrium hydroxide 0.1 molar. Volume hydrogen chloride for titration 1, 2, and 3 is still 10 milliliter. And for natrium hydroxide volume in titration 1 is 11 milliliter. And for titration 2 is 11.5 milliliter. And for titration 3 is 11.8 milliliter. And for change before added natrium hydroxide, the color is colorless. But after added natrium hydroxide, it turned to be a purplish pink. Reaction equation for this experiment is natrium hydroxide aqueous plus hydrogen chloride aqueous produce natrium chloride aqueous and water in liquid.
Next is the calculations. Next. The first one is calculations for the dilution using volumetric flex experiment to calculate the concentration 2 or the concentration of hydrogen chloride after the dilution. It used the volume 1 multiplied by concentration 1 equals to volume 2 multiplied by concentration 2. And the result is 0.5 molar. And the second one is calculations for the acid-base titration to calculate the actual hydrogen chloride concentration or the M concentration 1. It used the formula of the volume of hydrogen chloride multiplied by concentration of hydrogen chloride equals to volume of natrium hydroxide multiplied by concentration of natrium hydroxide. And the result is 0.1143 molar. The next is the analysis. the preparation or making and introduction of gas. The purpose of this experiment is to observe the chemical properties in the form of color, odor, litmus color, and characteristic of ammonium chloride and natrium hydroxide before or after the reaction. This reaction is done by reacting the ammonium chloride crystals with 2 molar of natrium hydroxide solution, which is then heated. The equation for the reaction can be written as natrium hydroxide reacted with ammonium chloride produce ammonium plus water plus natrium chloride. Ammonia gas has chemical properties that can change the color of red litmus to blue. According to the theory that base can change the color of red litmus to blue, it can be concluded that ammonia gas has alkaline properties. The reaction also produces a gas-induced odor, namely the odor of ammonia gas. The way to smell the gas is by waving your hand or hand panning from the mouth of the tube to the nose at a relatively far distance. When you smell the gas, there is a pungent smell of urine, which is the characteristic of ammonia gas. The heating in this experiment was carried out to break the hydrogen bonds in the ammonium chloride compound, which produce ammonia gas and water, so that it caused the appearance of pungent odor, which is the characteristic of ammonia. The second experiment is dilution using volumetric press. The dilution process is the process of mixing a high concentration solution by adding a solvent or distilled water so that the concentration decreases without the addition of a solute. In this experiment, no solute was added. The concentration of hydrogen chloride before the dilution was 0.2 molar with a volume of hydrogen chloride 25 milliliter, and then diluted with added distilled water until the volume reached 50 milliliters so as to form a dilution formula of volume 1 multiplied by concentration 1 equals to volume 2 multiplied by concentration 2. The purpose of the experiment is to reduce the concentration of the solution by increasing the volume of the solution using a solvent, so that the concentration of the 0.2 molar hydrogen chloride solution is reduced to 0.1 molar after adding the volume of the solution solvent or distilled water. Next is the dilution of concentrated sulfuric acid. Dilution of concentrated sulfuric acid aims to reduce the concentration of the concentrated sulfuric acid solution by gradually pouring sulfuric acid into the solvent. This is done because concentrated sulfuric acid is a substance that shows an exothermic reaction. If we put the solvent into a test tube that has a concentrated sulfuric acid solution, the heat release is so great that it can cause water to suddenly boil and sulfuric acid to splash. After putting the concentrated sulfuric acid solution into the distilled water, it was found that the solution experienced an increase in the temperature from the initial normal temperature to a higher or increased temperature. The increased temperature can be indicated by the warmth of the test tube when it's held. It can be concluded that this sulfuric acid dilution undergoes an exothermic reaction due to the release of heat from the system to its surrounding. The reaction equation is sulfuric acid reacted with water, produce hydronium ions and bisulfate ions. Next is the filtration. In this experiment, filtration of a mixture of lead acetate with sulfuric acid is done. Before reacting the two solutions, each solution is colorless. Then, after the two solutions are reacted, the color of the solution changes to white. The resulting solution will form a white precipitate because there are lead compounds that are difficult to dissolve in water. The precipitate formed is lead sulfate. In order to separate the lead sulfate precipitate from the acetic acid solution, it was filtered, and the results showed that lead sulfate settled on the filter paper in the form of white precipitate, and the filtrate was colorless. In this experiment, there were filtrate and residues, where the white precipitate of lead sulfate as the residue and acetic acid as the colorless filtrate. The reaction equation is lead, lead acetate reacted with sulfuric acid produce lead sulfate and 2 acetic acid. And the last is acid-base titration. Acid-base titration can also be referred to as the neutralization reaction, where acids and base react to reach the equivalence point. In this experiment, the solution used was the diluted hydrogen chloride, named hydrogen chloride 0.1 molar and natrium hydroxide 0.1 molar. The purpose of this experiment is to determine the concentration at the end point and the equivalence point by volume. The basic principle of titration is neutralizing reaction of hydrogen chloride as a strong acid is used as the tetrate and natrium hydroxide or the strong base as the tetrate. The titration experiment was done 3 times to obtain the constant results. In this experiment, using 10 milliliter of 0.1 molar hydrogen chloride, the hydrogen chloride was put into an Erlenmeyer flask, and the natrium hydroxide solution was added by the burette. Before the third titration of the hydrogen chloride solution, it was added 3 drops of the phenolphthalein. After the addition of the phenolphthalein, there has not been a color change in the hydrogen chloride solution because of the phenolphthalein works at pH of 8 until 9.8. And then add the natrium hydroxide solution to the hydrogen chloride slowly. And then slowly there will be a color change in this solution from colorless to pink or purple pink. This color change is a sign that the solution has reached the equivalence point. The reaction equation is hydrogen chloride reacted with natrium hydroxide produce natrium chloride and water. From the 3 experiments that have been done, in the first experiment, 11 milliliter of 0.1 molar natrium hydroxide was used. In the second experiment, 11.5 milliliter of 0.1 molar natrium hydroxide was used. And in the third experiment, 11.8 milliliter of 0.1 molar natrium hydroxide was used until the color of the solution changed to purplish pink. The purplish pink color indicates that the volume of the natrium hydroxide has been added too much that it has passed the equivalence point. In this experiment, the phenolphthalein is important to know the equivalence point because with this indicator, the solution can change color when the equilibrium reaction occurs. And next is the conclusions. First, ammonia gas is alkaline. This can be proven by changing the color of red litmus to blue. Ammonia gas is colorless and has a pungent odor that smells like urine. In concentrated sulfuric acid division, isothermic reaction occurs. The filtration of the solution resulting from the reaction of lead acetate with sulfuric acid produce white lead sulfate precipitate as a residue and acetic acid solution as a filter. Diluting the hydrogen chloride solution with a volumetric phase decrease the concentration from 0.2 molar to 0.1 molar. And last, the equivalence point of the acid-base situation is when the natrium hydroxide volume is below 11 milliliter, because the solution can turn to light pink.